Hello everyone. In this project, I want to explain how to use Autonics CT6S as a counter. There is a switch that it is in the series with the counter output 1 that enables the DC motor driver, and there is a potentiometer to change the motor speed. This is the current value, this is the preset value 1, and by click on MD button you can see the preset value 2 or PS2. In this project, the counter is counting the motor rotation. There is a sensor that gives a pulse for each rotation. If the counter reaches to the set point 1, the motor should stop until we reset the module. Power supply connects to the terminals 4 and 5. Output 1 is using in series to main switch to enable the motor driver. Terminals 8 and 9 used for sensor power supply and sensor output pulse connects to the terminal 6 that the name is input A or in A. This is the whole wiring for this project. To enter the parameter setting, hold MD button for 3 seconds. The first parameter is for choosing counter or timer mode, and here it is set on counter mode. Next parameter is input mode. Based on the manual, there are various type of input mode and I select here the type UDA. As you can see in the graph, input A is the counting input with rising edge. And if input B is low, the counting command is up and it is incremental. On the contrary, if input B is high, the counting command is down. The next parameter is output type and I select type T because I need the output 1 be on until the counter achieves to preset value 1, and then the output 1 will be off until I reset the counter. In this case, output 2 will be on if the counter is bigger than preset value 2, but in this project it is not important and I don't use output 2. By the buttons up and down, you can change the type of the parameter. Click on MD button to go to the next parameter. CPS is the maximum counter speed and is equal to 30 count per second. DP is used for setting of 6 digits or 4-digit type. This parameter is the width of external reset in millisecond. The input logic is PNP, and if you want to change it to NPN, you have to do it physically by opening the counter case, and there is a switch to change the input logic. SCDP is using for prescale decimal point, and SCL is prescale value. In my case, it is equal to 1. With prescale function, there is an interesting possibility to do positioning control by counter and encoder. There is an example here that the rotary encoder is connected to pulley and the output of encoder is connected to counter. If we assume that the pulley diameter is 22 mm and the number of encoder pulses per one rotation is 1000, then to obtain the prescale value, we have to divide the perimeter of the pulley to the number of encoder pulses per one rotation, and it will be equal to 0.069. In this case, we need 3 decimal point and the prescale value is 0.069. So by this setting, we can measure the displacement of the build. The next parameter is a start point value and it is equal to 0. This is the memory protection and it is set to clear, and it means that when the power is off, it resets the counter value. And finally, this parameter uses for locking keys and it is set to off mode. By clicking the MD button, it repeats the parameters. For coming back to run mode, we have to hold MD key 3 seconds. As an example, I want to adjust preset value 1 to 20 and the preset value 2 is a bigger number, and as I said before, the output 2 status is not important in this project. When I turn the switch on, the motor starts and the counter value is incremental. And when it achieves 220, the output 1 will be off and it stops the motor until I reset the value and it starts counting again. As I said before, the switch and the output 1 are in series to enable motor driver. So by turning off the switch, the motor stops and counter consequently. Thank you for watching this video. I hope that you enjoyed and please like this video and subscribe the channel. Have a good time.